In this video, we'll be looking at the steps for sketching the graph of a sine or cosine function. Press pause to copy down these guidelines into your notes. When you're ready to continue, press play. The example that we'll be doing is to sketch the graph of y equals 4 minus 2 sine quantity 3x minus pi. Our first step is to factor b so that the equation is in the form y equals c plus a sine b quantity x minus d. So because our sine is bumping up against the parentheses right here, and then our x, our variable, has a coefficient, we want that to be 1. So anytime that you have a number right here being multiplied by x, you need to first factor it out of the parentheses so that it's written out here. Now the b, won't change anything, but you'll notice that that does change the d value, so that our d now is pi over 3. Right, so that was step 1. Step 2, we want to find all of our values. Amplitude is the coefficient of the sine curve. So it's 2, but we want to make a note that our sine curve is negative. Because of this negative sign right here, we will start and head down when we start graphing. Then our period is 2 pi over b. B is 3, so we do one complete curve in 2 pi over 3 radians. Right, our vertical translation means that we're going to move our whole graph up 4, so plus 4. This means our center line is going to be at 4. And then our phase shift is the d value, and this is what we needed to get correct when we factored out our b value. But our phase shift is pi over 3 to the right, so positive pi over 3. Step 3, we want to draw our guidelines. Now we know that our center line is at 4, so whatever is added or subtracted out here in front, and sometimes you'll see this number that's sitting here by itself, you'll see it in the back of the equation. Just remember that whenever that constant right there, that's where your center line is going to be. So we draw our center line in, and that's just a guideline, so we make it a dotted line. Then our amplitude is 2, so that means that from our center line we're going to go up 2, and that'll be where the max hits, the maximum points. And then from our center line we go down 2, and this guideline is for our minimum points. Our beginning x value is our phase shift. So pi over 3 is our beginning x value. And notice that I wrote this as 2 pi over 6, an equivalent value. And you'll see why in just a minute when we look at our period. When we take our period and divide it into 4 equal parts, my period is 2 pi over 3. Dividing by 4 is the same as multiplying by 1/4, and I get pi over 6. That means for each quadrant, they're going to measure pi over 6. So here are my values that I'm going to be needing. First of all, my beginning value, my beginning x value is 2 pi over 6. And then these are my other values where I hit maximum or minimum or center line. So it looks like if I make all of my x notches sixths, I'll be able to do this pretty accurately. So I'm going to label this as pi over 6, and then 2 pi over 6, 3 pi over 6, and so forth. 6 pi over 6 is the same as pi, so I can just leave that. Alright, so my starting x value is 2 pi over 6, so that's right here. Since it is a sine curve, it normally starts at the origin, which is on the axis. But this one will be starting on the center line. And also, it normally heads upward. The normal sine curve heads up. But since I had a negative a value, I'm going to have to head that down. So I'm going to draw just a little thing here to remind myself that I have to go down. Then my next mark is at 3 pi over 6, and that's going to be here at my minimum guideline. Right. Then I have to hit my center line again. That'll be at 4 pi over 6. Then I'm going to hit my maximum line. That'll be at 4 pi over 6. Now these four values give me, along with my beginning x value, give me one period of my curve. And I can connect those with a smooth sinusoid graph. Now, if you're asked to draw two periods, we could just extend each of these, I call them quadrants, because with the normal sine curve, from 0 to 90 degrees is the first quadrant, and 0 is where it hits the center line, and 90 is where it hits the max. So each of these, for one period, you need 4 spaces. But if I needed another period shown, I would just continue my periodic function. At pi over 6, I have a max. At the y-axis, I have my center line. At negative pi over 6 is a min. At negative 2 pi over 6, I have the center line. And that would be one more period. That would be enough.